This is a very clever technique where we basically turned AI/ML on its head. Now, typically, what you do is you try to use AI/ML to identify malicious files. But what we have done here is we've created an AI/ML model to actually identify a benign file. So for instance, if you're downloading something from Office 365, or if your Windows machine is actually going to the Microsoft update server and downloading a patch or a software update, then we know based on these specific destinations, based on the file, that these are benign files. Now, as soon as we identify that the file is benign using AI/ML, we instantly deliver this to the end user because the chances of this being malicious is very low. So the risk is low. So we actually deliver the file right away to the end user while we still in parallel send a copy of the file to the cloud sandbox to identify, to make sure that it is really, really benign. However, in cases where the AI/ML model says that the file is not benign, we do not give this file to the end user right away. We actually hold the file. Given how the Zscaler Zero Trust Exchange is a scalable cloud delivered solution, we are able to use our proxy architecture to actually hold this file, run it through a full sandbox analysis, and only when we identify that the file is clean, we give it to the user. In cases where we find out the file is malicious, we block the file from being given to the user. Now, this allows us to actually save the end user from advanced patient zero attacks or files by utilizing sandbox technology in a very intelligent way, where we only use it when it's really, really necessary, thereby striking the right balance between security and productivity, giving a great end user experience. This is also underscores the power of actually delivering sandbox as an inline technology versus out of band, which a lot of other products do. Now, if we look at the analysis flow, this is what it looks like. Again, we are going into a little bit of more detail. So you have the inline AV and Yara scan. Yara, again, is a language which is used by malware researchers to define rules on malicious files, followed by the ML engine scan, where we do some level of scanning using ML to see if it is malicious or not, followed by static analysis. So static analysis is to analyze the code of the file at rest without detonating it to see if it is malicious or not, followed by dynamic analysis, which is when the file is opened in the sandbox, and followed by secondary static analysis, where we again do another level of static analysis to make sure that we have actually identified correctly if the file is benign or malicious. There are some statistics that we have shown on this slide. Of course, these statistics will change over time as we start seeing more and more traffic. But for instance, we see over more than 500,000 completely unknown, never seen before files, out of which 1,000 every day are unknown malware that we are analyzing on a daily basis that has never been seen before, which underscores the power of this cloud sandbox.